Hey guys, this is Al. I'm posting a response to a question that was posted on Piazza. Um, it's pretty difficult to answer these questions just by describing them. Some of the things are very visual, so I'm making this video. So this question, Kaye asks, I understand that complementarity means that higher levels of X causes additional units of Y to yield more utility. But wouldn't all indifference curves have this quality, as the further the curves is from the origin, the higher the utility level? If this is not true, how do you find if a utility function exhibits complementarity? So this is a good question. Um, so, and the answer is, it is true that the further a curve is from the origin, the higher the utility level. That's true. But that doesn't make it so that all indifference curves exhibit complementarity. Okay, and to see why, let's go over, this is Flash I have open here. So let me show you an example. So we have, okay, so these are the indifference curves for the perfect substitutes utility function. Okay, the utility function x plus y. Okay, u of x and y is equal to x plus y. Okay, and I have a grid here, and you can see it. So this is actually drawn to scale. So this is the x-axis over here, the y-axis over here. Okay, and you see I have this line, which I have labeled 3. This is the indifference curve associated with the utility level of 3. So all of the points on this line have a utility of 3. So for example, this point here is 0, 3. Okay, so x equals 0, y equals 3. Plug that into here, it has utility 3. So does this one. This is 3, 0, right? 2, 1, and 1, 2. They all have utility 3 according to this utility function. Okay, so let's imagine that I start here. So I'm at 0 units of x and 3 units of y. And I imagine what happens when I increase my consumption of x by 1. So I would start here, and I would move to here, right? So I've increased my consumption of x by 1 unit, while keeping y the same. Right? So now, how much have I increased my utility? Well, now I'm on the indifference curve for utility equal to 4. So I've increased my utility from 3 to 4 by increasing my consumption of x by 1 unit. Now, if I had started with a different value for y, if I had 5 units of y instead of 3 units of y, you can see it wouldn't really make a difference, right? I could increase my consumption of x, right? And this would move me from utility equals 5 to utility equals 6. Okay, so I still only increased my utility by 1 for increasing x by 1, and it didn't matter how much y I had, 3 or 5. Now, suppose instead, right, I'm in a situation where the indifference curves look more like this, right? So let's just start here, for example. So say this is basically, I mean, this is not exactly drawn to scale, but this is basically 3 units of y and 1 unit of x, right? And I imagine increasing my consumption of x by 1 unit just like before. Okay, now I'm here. Well, what's that? I'm in the middle of nowhere. There's no indifference curve, right? Well, of course, there is an indifference curve passing through that point, okay? I don't know what its value is equal to, but its value might be equal to something between 3 and 4, like maybe 3.5, okay? The point is, I increase my consumption of x by 1, and I don't increase my utility by anything close to 1, right? To increase my utility by 1, I'd have to go all the way here, right? So maybe I've increased my utility by like a third or something to 3.3 by moving from here to here. Now that's if y is equal to 3. But if I'm up here and y is at a higher value, right, I have more y now, I increase my consumption of x, and bam, I go from 3 to 4. That's an increase of 1, just like before, whereas when I was down here and I increase x, I don't move anywhere near that much in terms of my gain in utility. I only move from 3 to, let's say, 3.3. Okay? So 3.3, 3 to 3.3, 3 to 4. And what made the difference? It's the fact that I had more y in this situation than I did in this situation. Okay. Now, of course, that's what complementarity is. If I have more y, an additional unit of x increases my utility more. Okay? So I hope that answers your question. And yeah, I hope that answers your question.